For millennia, the Persian Empire was the beating heart of the Silk Road. Fast forward to the 21st century, and the map looks vastly different. Today, Iran navigates a labyrinth of international sanctions, proxy conflicts, and economic isolation. Cut off from Western financial systems and facing intense maritime pressure, Iran had to look overland to survive. It needed a lifeline that naval fleets couldn't blockade. Welcome to Tehran Tracks. Today, we are exploring the technical evolution and grand strategy of Iran's railway system. We look at how big this network really is, the heavy-duty tech driving it, and how an isolated nation reverse engineers and manufactures its own locomotives. The story of Iranian rail begins with a geopolitical earthquake. Built between 1927 and 1938, the Trans-Iranian Railway was a massive 1,394 km cutting through the Alborz and Zagros mountains. During World War II, the Allies invaded neutral Iran just to seize this railway, using it as the bridge of victory to funnel military hardware to the Soviet Union. But after the 1979 Islamic Revolution and the Iran-Iraq War, Iran's approach to railways shifted. Cut off from Western equipment suppliers, the government adopted a policy of autarky, strict self-reliance. The strategy? First, maintain the aging fleet through intense reverse engineering. Second, build a massive domestic supply chain to connect landlocked regional allies and bypass maritime trade routes entirely. So, how big is the network? Today, Iran boasts over 15,000 kilometers of standard gauge track. But geopolitically, Iran is a transit bottleneck. To the north, former Soviet states use a broad gauge. To the east, Pakistan uses a broad gauge. In west, Turkey and Iraq uses standard gauge, although Iran has strained ties with Iraq. To solve this physical barrier to trade, Iranian engineers designed advanced bogie-exchange facilities at border hubs like Saks. Here, hydraulic systems lift the train cars, allowing freight to swap wheelbases without unloading the cargo. Domestically, the network relies heavily on continuous welded rails (CWR), specifically optimized to prevent thermal buckling in the extreme heat of the Dashti-covered desert. While mostly diesel-electric, electrification is growing, notably on the Jol-Tabriz line operating on 25 kV AC overhead catenary systems, designed to handle the steep gradients of the northwest. Because of strict sanctions, Iran can't just buy trains from GE or Alstom. The undisputed giant in Iranian locomotive manufacturing is the MAPNA Group. Originally a power plant constructor, MAPNA shifted to rail to secure the nation's transit independence. At their massive facility in Karaj, they manufacture the MAPNA 24 locomotive. MAPNA initially used a technology transfer agreement with Siemens. When sanctions snapped back, MAPNA localized the tech. Today's Iranian locomotives use AC drive technology with insulated gate bipolar transistor (IGBT) inverters. This provides highly precise traction control for heavy freight climbing the Zagros mountains, powered by locally cast 16-cylinder diesel engines outputting over 3,000 horsepower. For rolling stock, Wagon Powers in Iraq is the primary player, forging heavy-duty freight wagons and passenger coaches using localized high-tensile steel. For maintenance, the Afrin Dry Port near Tehran is the central nervous system for freight sorting, while the Buff Junction acts as the primary maintenance hub for heavy-haul mineral trains. So far, The important rail hubs, manufacturing location, maintenance yard and port we spoke about are marked in this maps. Please have a look on it. Heavy hardware needs serious software. The Iranian government heavily subsidized rail research, primarily through the School of Railway Engineering at the Iran University of Science and Technology in Tehran, the only dedicated railway engineering school in the Middle East. Because Western signaling technology is embargoed, researchers here are writing the firmware from scratch. They are actively localizing automatic train protection (ATP) and centralized traffic control (CTC) interlocking systems to prevent collisions. Furthermore, the University of Tehran's metallurgy departments work with the Isfahan Steel Company to produce U-33 and UIC-60 rail profiles natively. By controlling the metallurgy, Iran ensures the tracks themselves are immune to import bans. Today, the Iranian government views the railway as a tool of economic survival. Under the nation's 7th development plan, the goal is to make Iran the indispensable land bridge of Eurasia. Geopolitically, tracks are cementing alliances. The Kaf-Herat railway pushes Iranian infrastructure into Afghanistan. The Shalmache-Basra line aims to link Iran to the Mediterranean via Iraq. Most importantly, the international north-south transport corridor allows Russian goods to reach Indian Ocean ports in days, bypassing the Western-controlled Suez Canal entirely. By combining localized heavy engineering and a geographically blessed location, Iran is attempting to engineer its way out of isolation, laying the groundwork for a new, multipolar trade reality. Infrastructure is destiny, and the rails running through Iran are shaping the future of global trade. Thank you so much for watching the video. If you enjoyed this technical and geopolitical deep dive, please hit that like button. Let me know in the comments below what you think about the future of the North-South Transport Corridor. And don't forget to subscribe so you never miss our next breakdown. You can also check out the other contents like this one, where you can learn how railways were instrumental in building empires, or you can watch the Vietnam's rail revolution or the evolution of railway in Korea from the channel. See you on the next one.